Um, an object is pulled south by a force F1 of 5 newtons and east by 12 newtons. Find the direction of magnitude. So the picture. Try again. Five south. It's 12 east, right? All right. Do you guys remember what magnitude meant? Yeah, basically the length of that vector. When you add two vectors together, the resultant vector would just be that one. Magnitude usually represented by absolute values, and it's the length. How would we find the magnitude? Pythagorean theorem, 5 squared is 12 squared equals x squared, and you guys remember the 5, 12, 13 triangle? So how about direction? So if it's a problem that has compass directions, like ships and airplanes, and in this case it was north and south and stuff, we used north as 0 degrees. And then what? Clockwise from there. So the direction will be how many degrees from north are we? And we can find it by finding this angle in the triangle and then just doing 180 minus that would work. How would I find that angle in the triangle though? Some trigonometry. Relative to this angle, we have opposite and adjacent, so that'd be tangent. Or to find angles, remember you have to do tangent inverse of opposite over adjacent. Do that. And that should come out as 67.4. And that's not the answer, but the answer is what this angle is right here. How many degrees from north are we? So 180 minus this angle would give us that angle. So it's 180 minus 67.4. So that's the direction. I remember number 2 being a kind of a pain in the rear. Not too worried about it, but we'll go look at it. Okay, in the diagram, AT to TC is 1 to 2. So that means basically TC is twice as long as AT. Express each following in the form R times vector U plus S times vector V. So basically we got to get the vectors they're describing just using vectors U and vectors V. So vector AB is kind of like vector U, but it's backwards. So how would we make the vector go backwards? Well, you just put a negative in front of it. That makes the vector go backwards. Vectors do have direction, so the order does matter. Vector AC. Well, if you go backwards along the vector U, like in the negative U thing, that gets you from A to B. And then you go down vector V, and that will get you from B to C, which essentially gets you from A to C. So it's going to be negative u plus v. Okay, vector AT. So vector AT based on the instructions was only half as long as vector TC. So what fraction of the way, if the ratios are like 1 to 2, what fraction of the way is vector AT along that vector? 1/3. It's 1 out of 3. So the vector we just found was this whole vector right here. So you could just do 1/3 times that vector. And okay, how do we get vector BT? Any ideas for BT? Well, if we started at B, how could we get to A? Just use vector u. And then how do we get from point A to point T? What vector could we use? Yeah, the thing we just did. That gets you from A to T. So if you did vector u plus that thing we just did, that would, they probably simplify that. That's like 1 minus 1/3 is 2/3 vector u plus 1/3 vector v. I'm thinking about the answers around here somewhere. I don't know. So here it is. Doesn't really matter. Either way is okay. All right. What are we on? Number 3. Okay, a plane is on a course of 320 degrees. Where would 320 degrees be at? It's 40 degrees short of 360, right? So it's, if I draw a north-south line here, probably need east-west too. It's 40 degrees short of 360, or you could say it's 50 degrees past. This would be 270. Anyways, speed of 480 miles per hour. So remember, vectors can represent speeds, distances, forces, like newtons, a measurement of force, energy. What are the north, south, and east-west components of its velocity vector? Okay, by north-south, they basically mean how far north or south did it move. That would be that vector. And by east-west, how far east or west did it move. So it's kind of like the x and the y coordinates. So how could we find x here? How far west did it move? Yeah, trigonometry. Yes, cosine. Cosine gives us adjacent, what we're looking for, over hypotenuse. So cosine of 50 equals x over 480. And similarly, sine of 50 would equal y over 480, opposite of hypotenuse. Then how do we solve that for x and y? Times 480 times 480. And that would give us our, how far west they went, or not how far west they went, but at what speed they were moving in the westward direction. That's basically, because we're not really talking about distance, we're talking about speed. But that tells you the speed in the westward direction and the speed in the northward direction. Okay, so on number 4 it says we've got a parallelogram ABCD. When it says parallelogram ABCD, you do kind of need to go in order. I could have gone ABCD or ABCD, it doesn't really matter. But you can't go like A, B, C, D, or you can't go A, B, C, D. That you gotta go around in a circle. Now, the way I wrote it doesn't really match these coordinates at all, but you don't really need, I mean, you could do a picture, but there was kind of a trick that helped us find these. You guys remember what it was? Yeah, the slopes. These two, or you can think of it like this vector should equal this vector on a parallelogram, or this vector should equal this vector. So what is vector BC? Let's try that one. In component form. You guys remember component form? Just like the x and y coordinate basically. So the x coordinate is going from 0 to 5. Doesn't match the picture, but that's okay. 0 to 5, so the x coordinate is increasing by 5. Another way you could do it is just do this x, x2 minus x1, y2 minus y1. The y component is going from -3 to 0, so it's increasing by 3. Okay, because it's a parallelogram, the opposite side should be parallel. They should have the same slope, the same direction and magnitude. So this vector 5, 3 is the same as this vector. Stevie Nicks. Okay, anyway, increasing by 5 and 3. So 1 plus 5, got my video taken down. 3 plus 3, and that would be that. Is there like a certain length of time you can play a song before it gets like copyrighted? I don't know what the rules are. I know on YouTube, if you're playing somebody else's video, you gotta pause every once in a while. That's more like a YouTube rule, I think. All right. Find the velocity and speed of an object that moves at a constant velocity, so its position times. Hey, the velocity, I didn't like this question very much. I probably didn't put it on the final, but I'll go ahead and tell you. The velocity is 1,4. That's what they mean by it. It kind of just tells you like where it's headed. This is -2 is kind of like a starting spot. T is kind of like time, and 1,4 tells you where it's going from there. Right 1 up 4. 1 in the x direction, 4 in the y. 1,4 is the velocity, and the speed was basically the magnitude, like how far is it moving per t units. So it's just Pythagorean theorem again. 1 squared plus 4 squared, so it's like square root of 26. Or 17 rather. I don't really like this number 5 question. The parametric equations, we did quite a few of those. Does anybody remember what that meant, parametric?